Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapiens Education. So today I am going to discuss about the ray optics part 2 video. So here already I have discussed about the reflection. So the topic which I am going to discuss about is the reflection part, right? So what is the refraction of the light? Refraction. So basically what we have earlier studied, it's is reflection. Now the term refraction. What is mean by refraction? So what happens when a light travels from one medium to another medium, so it will change the position, change the angle, change the path of the light, and this phenomena is known as refraction of light. So let us suppose this is your air interface and this is your water medium. So when a light travels from one this medium to this medium, so what happen? It will bend toward the normal. So let us consider this is your normal cut normal. This is angle of incidence. This is angle of refraction. Okay, this is angle of incidence and this is angle of reflection, right? So what will happen? It will bend toward normal. So when so what are the things which will change when it passes from the one medium to another? So first thing is direction. So definitely direction is changing. Second thing is speed. Definitely speed of the light will change. Speed of light will change. Next one is wavelength. So let us suppose earlier the light has a wavelength like this. So definitely light wavelength may be like become like this. So what will not change? Frequency will never change. Frequency means if there is a source of light and its frequency is like this, so what will happen? It won't change. So frequency cannot be changed. Color of the light, if it is red or orange or blue, whatever color of the light is there, so it will not change. Third one is your phase. So phase will not change. What do you mean by phase? See, let us suppose a light is moving in this direction. This direction, the wavelength is like this. So it will start from here. It won't start from here. It won't just revert its cycle. So it means phase won't change. I hope you have understood this. Now what is see here, refractive index to calculate the optical density. See here, which see, let us suppose air is your rarer medium. Air is your rarer medium. Water is your denser medium, right? Water is a denser medium. So when a light passes from rare to denser medium, so which has more optical density and which is more optical rare, we need to understand. So optical density. So refractive index can be defined as a speed of light in a vacuum divided by speed of light in a medium. So mu is equal to Cb. So mu is more, the optical density is that is optical density is inversely proportional to the speed of the light in a medium. So mu is inversely proportional to the speed of light in a medium. So let us suppose there is a diamond and there is a glass. Diamond has, let us suppose, a refractive index of 2.4 and glass has a refractive index of 1.5. So definitely the speed of the light will be more in glass and speed of the light in a diamond will be less. So I hope you have understood this. Now next is your what is the laws of reflection. So laws of reflection. Incident ray, reflected ray, and normal all lie in a same plane. Let us consider this is an incident light and this is a reflected light. And the refractive index of incident light is mu1 and refractive index of reflected light is mu2. Okay. So what will happen? What will happen uh, if this is an incident ray? So there will be an angle of incidence, and if this is a reflected ray, there is an angle of reflection. Okay. So what happens when we multiply mu1, that is the refractive index of the medium, that particular medium in which the light is incident or reflected, should we multiply with the sign of this angle and mu2, so the angle of this the light in this medium, that is r. So if there is a case where there is a two more than two surface, so let a light is moving like this and it is moving like this, right? So what will happen? So this is I1, this is I2, this is I3, I3 let us suppose, right? So this is your mu1, this is your mu2, this is your mu3. So sine of I1 into mu1 is equal to mu2 into sine of I2 is equal to mu3 into sine of I3. So this is what the relation is here. Okay. So this type of relation can be used. Okay. So it will be very much helpful in future. So next, one more important phenomena is that the ratio of the refractive index mu to 1 is equal to mu2 by mu1, right? Refractive index of a medium 2 with respect to 1. What is absolute refractive index? See, let us suppose refractive index of a glass with air I am comparing, or a vacuum. Refractive index of diamond with air we are comparing. Refractive index of any other substance, tryptylene with air we are comparing. Air or vacuum. So we will give the same, because the speed of the light in air as well as vacuum are same. So what happens, so this air or a vacuum is common to everyone, so we can write directly mu g, mu d, mu t. So it means a is hidden, and this is known as absolute refractive index. Absolute refractive index. I hope you have understood this. Now see here, next is your, see here, we need to prove that when an light is passing through this, light is incident on this any slab. So what will happen? It will bend toward this and again come out. We need to prove that light is changing the path as well as it is parallel to the initial one. So we need to prove. When we will do this, so what will happen? This is an I1 and this is your R2. So when I1 will be R2, then it means that the both the light will become parallel. So for this we will have, let us suppose, see here, as we know that the laws of reflection mu1 psi I1 is equal to mu2 sin R1. So mu2 by mu1 is equal to sin I1 by R1, we can write it. Again, when you use this one and this outside, so mu2 sin I2 is equal to mu1 sin R2. See here, I2 and R2. From here also, mu2 by mu1 will be equal to sin R2 by I1. Okay, so this is equation 2. Now from equation 1 and 2, what we have observed, that mu2 by mu1 both have a common, so we can equate this both, so we can write directly sin I1 by r sin R1 is equal to sin R2 by sin I2. So from here what we observe, since see I2 and R1, that is I2 and R1 both are common angles, so this can be cut out. So when you remove this, so what will happen, from here I1 I1 will be equal to, sorry, yeah, see uh, I2 is equal to R1. So because this angle and this angles are equal, so that's why this both will be cancelled out. Finally, we are getting sin I1 is equal to R2. Now from this, what we can infer, that I1 is equal to R2. So this incident angle and emergent angle are same. So it means both the lines are parallel, but it has been shifted. So when it has been shifted, so this is known as lateral shift. Now we need to find this length PQ. So that is known as lateral shift. How you will find lateral shift? Now from here, if you observe this triangle, like this, so what will happen? Sine delta is equal to PQ, that is this length, divided by OP. That is this one, OP. PQ divided by OP, perpendicular by hypotenuse. So from here, PQ is equal to OP sine delta. Now sine delta, when you observe properly, so this is a delta and this is I1, but this whole angle is equal to I1. So when we can directly write here, I1 is equal to R1 plus delta. So from here, delta delta can be written as I1 minus R1. So finally we have got I1 minus R1. Now from here you can observe this triangle. So when you observe this triangle, so what you can infer, cos R1 is equal to perpendicular by hypotenuse, that is MP, or OM by OP, right? Base by hypotenuse, not perpendicular. So OM divided by OP. So what is OM? OM is the thickness of the slab. So here we can get T divided by OP. Okay. So from here, OP is equal to what? OP is equal to T by R, cos R1, right? So from here we can OP is equal to T by cos R1. So from here finally we have PQ is equal to T by cos R1 into sin I1 minus R1. Just you put the values, because see here, OP we have got T by cos R1. So finally PQ is equal to OP, and hence this is your lateral shift only, lateral displacement or lateral shift only. Okay. So I hope you have understood this. So finally we will come in the next video. I will discuss a lots of things. So thank you for watching my video.